You know, every time you flip a light switch, you're tapping into this massive, invisible giant that's working around the clock to power our world. So in this explainer, we're going to pull back the curtain and see how these incredible power plants actually work.
So here's our game plan. We'll kick things off with the basics. What even is a power plant? Then we'll follow the journey from fuel all the way to your home. After that, we'll check out the whole menu of energy options, talk about their impact and efficiency, and finally, we'll look at what's coming next for the future of power. Let's get into it.
All right, first up, what is a power plant? I mean, we talk about them all the time, but what are we really talking about?
Okay, so at its core, a power plant is basically a giant energy converter. Its job is to take one form of energy, like the chemical energy locked up in coal or the kinetic energy of falling water, and turn it into the electrical power we need for, well, everything.
And it's so easy to forget they're even there, right? But these places are literally the beating heart of modern life. They're the hidden engines keeping our lights on, our phones charged, and, yeah, our whole world running.
So how does that incredible conversion actually happen? To figure that out, let's take a look inside the most common kind of power plant out there, a thermal plant. Because once you understand how this one works, you pretty much get the foundation for all the others.
It's this really cool four-step journey. Step 1. You burn a fuel, like coal or natural gas, to boil water and create a ton of high-pressure steam. Step 2. That steam blasts into what's basically a giant, high-tech fan called a turbine and makes it spin like crazy. Step 3. That spinning turbine is hooked up to a generator, which uses magnets and wires to create electricity. And finally, Step 4. A transformer cranks up the voltage so that electricity can travel efficiently all the way to you. So if you remember one thing, it's this chain of energy transformations. It goes from chemical energy in the fuel, to thermal energy in the steam, to mechanical energy in that spinning turbine, and finally to electrical energy coming out of the generator. This whole sequence, it's the secret sauce behind most of the power generated in the world today.
But here's the thing. Burning fuel isn't the only way to get that turbine spinning. There's a whole menu of energy options out there, and trust me, they are not all created equal. Each one has its own pros and cons.
So let's talk about efficiency for a second. And really, all that means is, how much of the energy you put in do you actually get back out as electricity? The difference can be absolutely massive. Look at this. A hydroelectric plant can be around 90% efficient. That's incredible. But then you have solar, which is closer to 20%. That means a full 80% of the sun's energy hitting that panel is just lost, mostly as heat. And that gap, well, it changes everything. The cost, the amount of land you need, you name it.
And this chart really gives you the whole picture. You can see thermal and nuclear plants are hanging out in that 30-something% range. Wind does a bit better, but look at hydro.